Welcome back, everyone. We're heading to our last talk before the lunch break. And we have now the privilege to listen to Lukas Vileikis, who is a technical evangelist at several nines. And today he will walk us through how and why you should keep a close eye on the performance of your open source databases. And this will be a live talk. Lukas will be available at the end to answer your questions. So please drop them in the Q&A section as he goes along. Welcome, Lukas. You can take it from here.
Thank you. Thanks a lot. So welcome, and I hope you enjoy this talk. So let's start again. So the importance of performance in open source databases. Now, if you are a MySQL DBA or an Oracle DBA or a Sybase DBA or even a developer, you probably know how important the performance of your open source databases is. Now, performance and security of open source databases, it's everywhere. Every day we hear about data breaches here and there. We hear about queries slowing down. We hear about developers giving advice to other developers how to improve the performance of their database instances, blah, blah, blah. So in this talk, we're going to go through why is it important to monitor performance in your open source databases and what can happen if you neglect to do that. So before we get rolling, I should probably introduce myself. At work at, as I was introduced, I work at several nines. I'm a technical evangelist. We have former MySQL, Percona, and MariaDB staff. I'm a MySQL guy. I work with MySQL for 8-9 years now. I run one of the largest and fastest data breach search engines in the world over at breachdirectory.com, where basically I let people check whether their identity is exposed at a data breach and help them protect themselves. I also blog at multiple blogs. I blog with the cyber police. I blog at several nines. My blogs are replicated over to Dev2, to MySQL, to MariaDB, and also run my own blog at lukasvileikis.com. I talk at conferences. You can see me here. You can see me at Build Stuff, Dev Talks. If someone attends TEDx, I'm usually present there. I talk at Percona Live and other things. I found a couple of bugs in MySQL a couple years back and recently. And I'm also writing a book on MySQL with a publisher based in New York, A-Press. So in this talk, what we're going to do is we're going to walk you through why you should improve the performance of your open source databases. We're going to go through MySQL engines. MySQL is one of the relational database management systems. We're going to go through why you should optimize the schema and data types of your MySQL database instances, how you should optimize the performance of your queries, how indexes work. We're going to go through a couple of advanced MySQL features, and we're going to go through a couple of tools designed to improve the performance of your open source databases. Do note that the majority of this talk will be focused on MySQL and MySQL performance, but the majority of this advice that is going to be given out is not really specific to MySQL, and it can be applied to all kinds of databases. Doesn't matter whether you are a MariaDB, Percona guy, or an Oracle guy, or a Sybase guy. It's pretty general. Just a couple of changes here and there, and you should be good to go. So we're going to be starting with why you should bother with performance in the first place. Now, indexes, performance, partitions, and similar things, they can increase your database performance sometimes by hundreds or thousands of times. Indexes and partitions are very, very crucial to performance, and they're one of the first things that MySQL DBAs and developers, they talk about when they talk about database performance. Because database performance, it's only really talked about when your queries are slow, when your application is underperforming, and when you have slow database instances in general. Now, there's a lot of things you can do here. For example, as I said, indexes and partitions are your friends, right? Keeping an eye on performance is always important, but it might be even more apparent when you see that your database instances are no longer performing at the best of their ability. And if you, for example, need to change your server or something like that. Performance can also keep your business afloat. I was talking how performance can help keep your business afloat. You can have no complaints, you will have happy customers, and you will have no issues for the staff in your organization if your databases will be performant and if your databases will be secure. But for that, you need to put in a lot of work, quite a lot of work. Now, all databases or relational database management systems, they have a couple of specific options unique to themselves. They usually have one or two files where those options are defined. The majority of this talk will be focused on one of the most popular MySQL engines, InnoDB. And for example, here, what you can see here is all of the options that are relevant to one of the MySQL engines, InnoDB. We're going to go through what it is and how it works in a second. But as you can see, there are a lot of things that can be configured. For those who are not very MySQL savvy, for example, the InnoDB data file path, it depicts the file where data from InnoDB tables will be stored. The InnoDB buffer pool size, it's the memory buffer that InnoDB uses to hash data and indexes of its tables. And for example, the log file size, the larger you have it, the less recovery time you need in case of a crash. The log buffer is used to write the log files on disk. The flush log and transaction commit is basically can make your database instance either ACID compliant, which we're going to be talking about what it is in a second. Either it can improve your performance at the cost of ACID compliance. So basically, ACID compliance is atomicity, consistency, isolation, and durability. It's a set of 4 database properties that ensures your database will be performant whatever happens. And for example, when you have the flush method, the InnoDB flush method, one of the most important parameters for one of MySQL's engines, InnoDB, you have a couple of options here too. MySQL DBAs usually know this, but if you're a developer, you need to keep in mind that you have, for example, a couple of options that either used on Windows or on Linux. You have a couple of options as well that are used for internal performance testing and they're therefore unsupported. But most MySQL DBAs, they use ODirect because it makes your data more stable and data consistent. There is an option called O_desync, but that makes your database no longer ACID compliant. But basically, it makes so your database is faster than with ODirect. But with ODirect, you get ACID compliance. So this is a couple of things you will need to keep in mind as we go through. Now we're going to come back to these options a couple of times during this talk. So if you don't remember everything that I said, don't fret. We're going to be explaining everything in more detail as we go. So in order to understand why these options are so important, we usually have to go through the storage engines that are available in the open source database management system. For this example, we're going to be using MySQL, and MySQL offers a couple of database storage engines. The most frequent used option is InnoDB, which offers high performance. It offers the ACID model, which, as I said, is a set of 4 database properties that guarantees data validity despite of any power failures or whatever. So basically, if you're running a database query and your power goes out, you will have no issues with your database instance whatsoever because ACID compliance, it will make sure that only integral data will be written to the database. In other words, only data that cannot be lost during power outages, any crashes or whatever. And it also provides you data integrity. MySAM storage engine is usually widely known to count rows very fast due to the fact that it stores the record count in its internal counters, which InnoDB does not. So count queries, for example, if you need to count all of the rows existing in your tables, will be significantly faster on MySAM due to the fact that it stores the internal counter inside of it than on InnoDB, because InnoDB does not. Memory, on the other hand, it stores all of its data in memory, but leaves data vulnerable to crashes because in memory it's volatile, really. You have another storage engine. You have CSV, which stores data as comma-separated values. basically does not support any indexes or partitions, and all of your columns must be defined as not null. And you have a couple of other storage engines as well. We're not going to be covering them all in this talk, but what you should know is you have Archive, which is to be used as an archive for legacy information. A black hole storage engine, it basically stores nothing. It throws all the data away, and it's usually used to improve the performance of your, for example, PHP applications. Merge storage engine, it's usually a collection of tables running the MySAM storage engine, and it basically allows you to merge a couple of tables into one. And also you also have an example storage engine that can be used as an example how to build storage engines in MySQL. Now, in order to optimize one of the storage engines, as I said, you have one file in InnoDB in MySQL. It's called my.cnf, and my.cnf file, it consists of every bit of a piece and information that is relevant to improving the performance and security as well of your MySQL installation. For example, in this talk, we're going to be covering InnoDB, but there are, in the same file, you can find also parameters relevant to one of the less popular MySQL storage engines, for example, MySAM. We're going to be starting from the top. So basically, as you can see, the first parameter that you have is the InnoDB data file path, which basically depicts the file where InnoDB stores all of its other files, all of its data, right? The easiest way to configure this parameter is to set it to be auto-extending. And the trick with this is that IBData1, the file, it stores all of the data relevant to InnoDB. It stores data, it stores indexes, it stores multi-version concurrency control data, it stores metadata and such things. So it's really important to make this file as big as you can without you needing to reset this parameter later on, because as you go along, as your MySQL databases grow, you need to keep in mind that the IBData1 file, it cannot be shrunk. It can only grow. There are ways to kind of get around this, but they're really hard to accomplish if you don't have much experience in the MySQL space. InnoDB buffer pool size is one of the most important parameters in the MySQL space. Basically, InnoDB buffer pool size, it depicts the size of the buffer pool, basically the size, how much of your RAM can InnoDB occupy. The more RAM you allocate to InnoDB, the more faster your, say, insert queries will be, and the more faster overall performance of your database instances will be. Most experienced MySQL database administrators set this variable to 60 to 80 to 60, 70% or 80% of the available RAM in your system. Now, log file size is directly dependent on the buffer pool size. The log file size, as you might know, if you're a MySQL DBA, if you're not, well, you might not know, but it's the larger it is, the more transactions can be run without needing to write the logs to disk before the transactions commit. Now, the larger your log files are, the less recovery time you need in case of a crash. And you need to also configure your InnoDB flush log a transaction commit parameter, because this parameter, as I said, it has three available values. It has 0, 1, and 2. And basically, with default value is 1, which makes your database as ACID compliant, which is, as I said before, remember, ACID compliance makes sure that your data in your databases stays integral despite of any kind of power failures or other such mishaps. But you can also have a value of 0 or 2. That means that you don't have ACID compliance, but you have a little higher speed in terms of inserting your data. But then once your database crashes, your data might be lost. You can lose data relevant up to the last second that your transactions were running. The flash method, it defines the flashing method used by InnoDB, and the best choice is O_direct, which is essentially stable, but more data consistent, but slower than its counterpart, ODsync. ODirect will perform all of the I/O operations while bypassing the operating system's hash. So here's why it's so important. Once you have optimized your database inside of the file, inside of the myCNF file for MySQL, it's time to probably optimize your schema a little bit. Now, the first thing you need to do is define the requirements for the database. You need to define what kind of data are you storing. You need to answer the question whether you deal with big data or not. That would be a decisive factor whether to use basically MySQL, MariaDB, MongoDB, or any kind of other database management system. What kind of SQL queries do you run? Do you run create? Do you run read? Do you run update? Do you run delete queries? It's all also relevant on your database schema. And you can also need to answer the question, do you need indexes? If you do, why? If you do, why? And if you do, what kind of indexes do you need? Because remember, most database management systems have a couple of types of indexes. And you also need to keep your database schema simple and avoid reserved keywords. You need to normalize your database schema to avoid occupying space on the disk that is unnecessary. You need to keep convenience and usefulness in mind, and you need to also analyze use cases of more successful projects that may be using a database schema differently than you do and may be getting better results than you do. So database schema is really important when dealing with your data because, for example, database data types, which is a part of your schema, which we are going to be getting into in a moment, are a really big part of how you store your data. Because if you define the wrong data types, you can ruin your whole experience with your project. You can waste disk space, and you can do other things as well. So it's really important to optimize your data types when you're dealing with your database schema and databases in general. So for example, MySQL has a couple of data types available for you to use. It has integer and float values, which occupies 4 bytes of storage. It occupies 4 bytes of storage. The year data type, it occupies 1 byte of storage. Every character, the date data type, it occupies 3 bytes. You also have the time data type, which occupies 3 bytes plus fractional second storage. You have tiny blob and tiny text, which lets you define the length in bytes that you need your tiny blob and tiny text data types to occupy. And it also takes up 1 byte more of storage than you specified. You also have blob and text values, which basically can be used either to store long text values or blobs. It takes the defined length in bytes plus 2 bytes of storage. You can have medium blob or medium text for medium sized blobs or medium text values that are basically long, but not long enough to satisfy the usage of long blob and long text. And you have also long blob and long text, which is essentially used for extremely long text values. It takes defined length in bytes plus 4 bytes of storage. So you need to keep it simple as well. You need to understand what impact indexes do on your data types, because some indexes, it may work differently on different data types as well. So you may need to keep that in mind as well. We unfortunately don't have time to get into all of this in this talk, but you need to refer to the MySQL documentation and you will learn a lot more useful information in this regard. When it comes to optimizing the performance of your queries, for example, there are multiple tools that can help you with this task. For example, cluster control. Cluster control is essentially an open source database management system. It can help you back up your data. It can help with monitoring and alerting, deploying and scaling, upgrades, patches, security and compliance of your database instances, and also query performance optimization. It can help you see what kind of database queries that you have are underperforming, what kind of queries are performing well, etc., etc. And when you're optimizing your queries, it's really important to understand what you're optimizing in the first place. If you're optimizing queries that, for example, create data, you're probably optimizing in MySQL, bear in mind, you're probably optimizing insert queries. If you're optimizing reading queries, you probably need to optimize select queries. If you need to optimize updating queries, there are a lot of other things you need to do. If you need to optimize the deletion of your data, there are also other approaches you can take. Most MySQL DBAs, they optimize select query performance, and when they have a lot of data, they optimize insert query performance, because when you have a lot of data, it's really important to load other types of data into your database instance as quickly as possible and make sure that you're dealing with the most quality data that is possible. So basically, in this case, what you should keep in mind, we're going to be getting into the types of these queries in a moment, but keep in mind that indexes and partitions help select queries, but they slow down inserts, updates, and deletes, and vice versa. If you don't have indexes, your select queries will probably be a lot slower, but at the expense of speeding up your inserts, updates, and also deletes. So this is something you need to keep in mind. Now, if you need to optimize your insert queries, you need to, first of all, keep in mind that you need to take advantage of default values, because the queries that would run it would that way take a little less time to execute. You can also take a look at load data in file if you have a lot of data that you're dealing with, because it's designed to load big data sets into MySQL along with a couple of bells and whistles. Basically, it can skip lines or columns, it can load data only into specific columns, it can have less overhead for parsing data, etc., etc. And also, you need to keep in mind that you can combine many small operations into one large operation when you run insert queries. And basically, to do that, you need to specify values that you need to insert, and then you specify a comma, and then you specify another set of values that you need to insert, and then specify a comma, and then another set of values, and you go like that. So there, this is insert performance at a high level. But if you are a developer, you're probably looking at optimizing your select queries, let's be fair, because most developers, they only look at performance optimization when their select queries are slowing down. And as a result, most of them, they optimize select queries and optimize everything else afterwards, optimizing select queries. So to optimize select queries, you need to, first of all, take a look at indexes. As I said, indexes can drastically speed up select performance, but at the expense of slowing down inserts, updates, and deletes. You need to figure out what indexes would be actually useful to your database instance by using explain. You need to understand also that queries are tasks that are composed of subtasks. And in order to maximize their performance and minimize the time they take to execute, you need to either eliminate these subtasks or make their execution time a lot slower. So that's the crux of it. You can also take a look at the query hash, but the query hash, bear in mind that it's deprecated since MySQL 5 point something. So it's not really a good fit if you're using a newer version of MySQL, but if you're using an older version, that should fit. Now you probably need, if you're optimizing all kinds of queries, you're also optimizing deletes and updates probably. So we're going to be looking at that as well. To optimize the performance of deletes and updates, first of all, you need to remove the indexes and the columns that you're indexing, that you're running queries against. The core reason for this is basically when you are updating data, if you have indexes, if you have a lot of indexes on your data, on your tables, the indexes will have to be updated together with the data. And such, if you have a lot of data, it can take a really long time to update everything. And you can also take a look at executing updates in small batches to lessen the load for your database instances. And also you can use a life hack. Some MySQL database administrators, when they have a lot of data, they, instead of using update, they actually use load data in file, and they only load data into a specific part of a column. So load data in file is a query that comes with, as I said, so to say, a lot of bells and whistles, because it can be made to skip certain columns, and it can also help when loading data into a column with no values. It basically, you need to use load data in file and then specify a column name at the end. So the syntax looks a little something like this. You use load data in file, and then you specify the file that you loaded the data from in quotes or in double quotes, and then you use your column name that you need to load data into, that you need to update the column with at the end, and that's the crux of it. So basically, the query performance, it doesn't end here. However, if you need to optimize delete queries, you probably are facing issues with a lot of data in your database instances. And optimizing such queries is not a very frequent task that MySQL database administrators or developers alike face, but it's also a problem nonetheless if you don't know how to do that properly. In this case, remember that there are a couple ways to basically optimize delete query performance. You can, first of all, if you are deleting rows from a large InnoDB base table, InnoDB, remember, is one of the core MySQL engines. First of all, you can select rows not to be deleted into an empty table that has the same structure. Then use a rename table to rename the original table to some different name than the original table, and rename the duplicate table to the name of the original table, and then drop the original table. That way you can have a lot less load to put on your database instance. In this case, remember that if you have to delete all of the data in a given database or in a given table, you can also use truncate table, which is significantly faster than delete queries when deleting data from an entire table. Truncate table will basically instantly remove all of the data existing in your table. So if you have to remove all of the data, you should probably use that one instead. As I said, a lot of database management systems, they have a lot of also indexes. Indexes are basically data structures that are used to find rows that match a where clause more quickly. And basically, when indexes are in use, certain rows, they can be instantly skipped at the expense of basically taking up a lot more space on your disk drives, which are pretty much cheap these days, let's be fair. You can have improved performance by hundreds or even thousands of times if you use them properly. But in order to use them properly, you must know a thing or two about index types in MySQL as well. Index types, basically, it comes with MySQL on its part. It comes with balance tree indexes. It comes with spatial indexes, it comes with hash indexes, it comes with covering, clustered, composite indexes, and a couple of other things related to, for example, dealing with geospatial data inside of itself. But the most frequent type of index that MySQL DBAs and developers will probably use is a balance tree index. It's the most commonly used index type. It's used with the equal, more than, or equal, less than, or equal, between keywords, and also like queries. So like queries, they allow you to search for a certain data set according to what it begins with or what's in the middle of it. Basically acts as a wildcard. In this case, when using like queries, you need to remember that when you use a wildcard in front of the like query, your indexes will not be used because there can be anything that the query begins with. If you want your indexes to be used when, for example, running like queries, you need to make sure that your wildcards are only at the end of the search statement and not in front of it. So in order to optimize your databases for high performance using indexes, you need to isolate your columns to make MySQL use them. So isolating columns, it essentially means that you do not need to have anything after the where clause. So in MySQL, queries that might use indexes might look something like select all from table where something equals something. And if you have, after the where clause, if you have where something plus one equals something, your queries will not be used. So basically, you need to make sure that only the column that you have indexes on is used after the where clause in order to make sure that MySQL uses it. Index selectivity, it might also help you determine how useful your indexes are. Prefix indexes, they can be useful if the data size you're using is large. So basically, with prefix indexes, you can index a part of the column and not in the entire column itself. And also composite indexes, they can consist of up to 16 columns, but you need to keep in mind that you need to only use covering indexes when you want MySQL to retrieve results from the index itself. And such, by doing so, save disk I/O. And now you need to refer to the MySQL and MariaDB documentation for more information, but I think it should be more or less clear what indexes can do. Now, in order to update your select query performance, most MySQL DBAs and many developers as well, they elect to use partitions. And partitions tables is basically a table with a couple of subtables. Partitions are basically subtables. And the partition tables are usually easier to maintain because you can delete and restore a partition rather than the entire table, which is very useful for entire tables. You can also back up and restore a specific partition. You can have quick data removals when using database partitions, and so on and so on. You need to also keep an eye out on log granularity. If you're using MySQL for other database management systems, you might have other types of log granularity, so it might not be as relevant as with MySQL, but when MySQL is concerned, you have a couple of log types you need to take care of. Row level locking and table level locking are the most frequent types, which basically row level locking means that only the row accessed by a transaction, it will be locked. And table level locking, it means that only one session could update tables at any given moment. Table level locking is usually pretty frowned upon by MySQL DBAs and experts because table level locking is supported by one of MySQL's obsolete engines, that is MySAM, and row level locking is supported by one of MySQL's flagship engines, that is InnoDB. Now, if you're tired with if you want your database instances to perform very well at, let's say, with big sets of data, you need to have indexes, partitions as well, and you need to partition your databases in such a way that data beginning with certain characters, say, goes into a certain partition. This is what's done with, for example, data breach search engines like I did with breachdirectory.com, which essentially is a data breach search engine that lets you see the exposure of yourself in a data breach. So basically, if your account exists in a data breach, it will say, well, your account exists, please change your password. And if it doesn't, it will say it doesn't. We're also working on animated movies to help people realize the extent of their exposure of a data breach in a data breach. And we also have a blog here and there. But as far as your database performance is concerned, if you're tired of monitoring it manually, you can use tools also like cluster control, which comes with many useful features, including database advisors. Most of the database monitoring tools have this feature, which it helps you monitor your database performance by monitoring your CPU and disk space usage, the performance of your engines, and your database size as well. You can also deploy load balancers with most of the database management systems. For example, Cluster Control and other database management systems as well, they provide a couple of load balancers that you need to use. They can let you import load balancers like proxy SQL, like HA proxy, high availability proxy, that translates to keep alive or max scale. So basically, in this case, you need to keep in mind when deploying load balancers that essentially you only need them when you have a lot of data. Database load balancers are essential because load balancers, they understand your database well, and they can direct the load of your database instances elsewhere, thus preventing the majority of the load hitting your database instance itself. For example, proxy SQL understands MySQL. It's a high-performance SQL proxy that accepts incoming traffic from MySQL clients and also forwards it to MySQL, to backend MySQL service. Essentially, you have traffic directed to your MySQL server and then forwarded to backend MySQL servers, thus reducing the load on your core MySQL server. Most database management systems and monitoring systems as well, they allow you to monitor your queries. Most of the tools, they can let us monitor top, slow, and long-running queries. They can allow us to view database connections or query outliers. Query outliers in this case basically are just queries that deviate more than 2 sigmas from the normal response time. And if you have a lot of queries, monitoring them with tools can be a really essential task, because tools can really optimize a lot of and speed up a lot of your manual tasks that you are doing. Most of the tools, they also have a couple of other options in the query field. They let you add, for example, partitions, which, as we talked about, basically are just partitioned tables that are composed of tables within themselves, or they can let you add indexes. Some of them let you run SQL queries on your database instance itself, so you don't even need to connect to your database to run the queries through a command line interface. Some of the database management systems, they allow you to see, for example, graphs. Graphs, they are really important, because if you see that they let you see that your database instance is not performing well by just observing a couple of images, let's say, on the screen. So basically, graphs, they are usually taking derived from a script that monitors your database performance internally, and if the database performance, it drops or is facing some sort of a, let's say, anomaly, the graph will obviously be a little different, and then you will be able to see what's happening in your database instance in the form of graphs. And if you see that the graph is going up and up, for example, if you see that the queries that are existing in your database instance instantly jump from, let's say, 5 queries to 500 queries, you will obviously know that something is wrong. If you ordinarily have, for example, 10 or 15 queries running at your database instance at any given moment, and then one day, bam, and you have 10,000 or 20,000 queries running at your database instance in any given moment, that's not a really normal sign, and you need to investigate that. So graphs can really help with that. In that case, you need to look at the graph, and you need to come back to your database instance and say, aha, do I need to optimize select queries? Do I need to optimize the reading of data, right? Do I need to optimize insert queries? Do I need to optimize how the data is acquired? Do I need to optimize the update queries, how the data is updated? Or do I need to optimize delete queries? Do I need to optimize how data is deleted, first of all? And then once you figure out what you need to kind of optimize, then you're able to derive from the information that you have, you're able to derive what kind of action you need to take. Do you need partitions? Do you need just basically split your tables into a couple sets of smaller tables? Do you need indexes, right? What kinds of indexes do you need, right? If you need, for example, balanced tree indexes, you need to remember that they are useful in most cases, but they might not be useful when you're dealing with, for example, geospatial data. For that, you have spatial indexes. If you're dealing with, say, queries that require a lot of specific work and they need to be running with, say, wildcards like the asterisk sign or the percentage sign to make people um, run queries that are not specific to that are not specifically defined, but basically they only have a part of the value of the row defined. So you need to have full text indexes. They can help with that. Full text indexes, they have a lot of their own nuances. For example, you cannot use with an eta sign, you cannot use a full text index if you have a lot of data on MySQL 5.7.26, which is a really unique bug, but that's how this is being fixed right now, and I hope it will be fixed, and etc. So in order to sum everything up, I know this was kind of a lot of information that you just got. To optimize the performance of your open source database systems, first of all, you need to understand what you're working with, right? First of all, you need to understand what you're working with. Do you need to optimize MySQL? Do you need to optimize MariaDB? Do you need to optimize your Percona server? Do you optimize MongoDB? Maybe optimizing Oracle, maybe Sybase, right? And then you decide, once you know what you're optimizing, you need to decide what kind of steps do you need to take, right? What inside of the database instance specifically are you optimizing? Do you need to optimize select queries? Do you need to optimize update queries, delete queries, insert queries, and then act accordingly? As I said, the majority of this presentation was tailored towards MySQL database administrations, towards MySQL database administration cases. But in general, the most general advice I can give you is that you need to make the most of your database instances in general by choosing the best storage engine for your use case. The majority of the open source database management systems, they have a lot of storage engines that you can choose from. As we went through, MySQL has a couple of them as well. For example, InnoDB is the most frequently used one. And once you choose the storage engine, you need to go and optimize your schema, because your schema is essentially the core of where your data will be located. And then you need to look into your data types. Then you need to know when to use indexes or partitions. You need to know how to keep an eye out on your queries, like, remember, indexes, partitions, and also load balancers, and also monitoring tools. And you also need to keep an eye on your settings and the server itself. So basically, the settings, it will depend on what kind of operating database management system, you are using. If you're using MySQL, you probably need to take a look at my.cnf. If you're using MySAM, the settings will be at the top, one of the MySQL storage engines. Remember, if you're using other storage engines like InnoDB, the settings will be probably at the bottom. If you're using other storage engines, you need to direct yourself to MySQL documentation or MariaDB documentation. So if you're using MySQL, this is what you need to do. If you're using other database management systems, the processes that you need to take are pretty much extremely similar, but they might differ here and there. So you need to direct yourself to the documentation. So Thank you. I hope this presentation was helpful and it helped some of you optimize the performance of your open source databases. As I said, this presentation majority of it was tailored towards MySQL database administrators, but if you're not a database administrator, you can also take some information that I gave away, because the majority of the information that I gave away was pretty general and applicable to a lot of use cases. I can be reached via email if someone needs to contact me, and if someone needs to check if their identity is at risk of being stolen, I also run a data breach notification service. So thank you and have a great day. Thanks.
Thanks for the Lukas. So it's really, it's been a while since I used MySQL, but this was a good refresher, I think. Maybe we'll give 1 or 2 minutes for people to post questions if they have any. Otherwise, they can just reach out to you on Slack. And maybe I can ask a question from a non-DBA perspective, because back in the day, I made some DBAs a bit mad, I think. So from a DBA perspective, what is like the most common mistake people do when building their queries that you see causes like big performance implications? So like what comes up more commonly that is really bad, that really badly hits the database, but as a user, you might kind of overlook it?
The majority of it is related to poorly optimizing the schema and either not using the indexes properly, either using different types of indexes that you don't need. And the majority of people, they usually waste space, a lot of disk space, by optimizing database data types. But they, as they don't know that different data types optimize different, that take up different amounts of storage on the disk, they usually lose a lot of precious disk space that they can use for other things. Mm-hmm. And also, majority of people, they define indexes that the database instance doesn't use, and they do not make sure that the indexes that they defined are actually used by the database instances. So these are the most common frequent things.
Yeah, I think as a user back in when I was using MySQL, it was mostly we in the middle of the night just figured out that like something query just ran out of memory, and it was usually because it was doing full table scans instead of actually using the indexes. So yeah, so this was really interesting, and I think also users should be a bit more aware of this kind of background information so that they don't put together queries that then get terrible plans that just ruin your life if you're a DBA.
Yeah, definitely.
Okay, I think we have no questions, but for everyone watching the talk, just feel free to reach out to Lukas. I guess you'll be around on Slack.
Yeah, I will. Yeah.
Thank you so much for your great talk, and enjoy the rest of the conference.
Yeah, thank you. Bye.